Greetings, and gather round, children, while I tell you a tale of pioneers, innovation, triumph, loss, and colossal cock-ups. Many moons ago, there were a company by the name of Celerity Computing, who were trying to make the meanest little computers that they could, generally with smatterings of RISC and a healthy dose of multiple CPU. While working on multiprocessor mini supercomputers, the Celerity 6000, case in point, they ran out of money and ended up being bought by another company called Floating Point Systems, who made, as the name suggests, floating point coprocessors for mini computers as well as array processor style mini supers as well. Working up from their purchased Celerity intellectual property, they put together the Model 500, which finally folded into, wait for it, Cray. In 1992, the Cray SMP was a multi-processor super built around SPARC processors with an attached array processing system. This portion of Cray, building systems around other people's processors, was named Cray Research Super Servers. Cray generally built large array processors and vector processors of their own in-house design, whereas CRS built them around other people's processors, so that you would have a large multi-processor system using off-the-shelf processors. So, CRS followed up the SMP with the CS6400, and this had 64 Super SPARC processors and up to 16 gig of RAM. They used a bus design that they borrowed from Xerox, the XD bus. The CS6400 also used an SSP, which is a system service processor, which connected to the 6400 through a JTAG to configure the bus and other sundry systems. Okay, so, with me so far? Good. Now we come to the bit that we actually give a damn about. CRS began working on the next machine, codenamed Starfire, which would use the much newer UltraSPARC 2 processors and would be built on top of the Gigaplane XB interconnect between processor and memory. Capable of up to 64 466 MHz UltraSPARCs and 64 gig of RAM, she was a monster. Starfire was built for reliability as well, with very high fault tolerance, flexibility, allowing you to segregate the system into domains running independent operating systems. And this is right about when SGI bought Cray back in '96. Now, SGI clearly didn't want to have a super built on Sun processors. That certainly wouldn't do. And so they sold the CRS division to Sun for around $50 million. Unfortunately for SGI, and fortunately for Sun, the Starfire, which is now named the Sun Enterprise 10,000, was a massive hit, generating, according to Scott McNeely, the CEO of Sun at the time, several $1 billion in sales. Score, right? So, that brings us to this. This is my Sun Enterprise 10,000, which I managed to get from a friend at Purdue. It has full 64 processors, 64 gig of RAM, and it's almost ready to rock and roll. My E10K had a minor incident on the trip back. We used carpet to wrap around the system to ensure it didn't get the hell scratched out of it with its beautiful side skins. And unfortunately, the carpet was filled with sand. Don't ask me. Just leave it at that. And so I've had to spend the last week vacuuming sand out of every little nook and cranny in the system, which, when you see as big as it is a total bitch. Anyways, the E10K itself. So, as I mentioned, it was capable of what they called dynamic system domains. This meant that you could partition the system into several logical computers. So say that you wanted a 16 processor Sun system. You hook your 4 blades together and you say, this is one computer, and this is one computer, and there you have 2 complete systems that run the OS independently of each other. Now they ran Sun OS, or Solaris obviously. As well as that, they had what was called dynamic reconfiguration, which meant that if a system component failed, you could simply, through the SSP, tell it to offline that component and you would remove it. So, for example, a miner Say one of the fan trays croaked. You tell the system to power down the fan tray. The lights will go from green to orange to red. When they're red, it's time to yank them out. You drag them off. Slap the new one in, tell the SSP to bring that fan back up, and you're good as gold. Say you have all 8 system boards, so 32 processors, running in a single system. And one of the processors in SB2 is shot. So you tell through the SSP, the system, that one of the processors is bad, which, of course, allow me to rephrase. The SSP is what told you the processor was bad in the first damn place. You tell the SSP to offline the board. It'll shut down the processors. Everything that's in RAM on this system board gets migrated to the other system boards, and it's completely turned off. The OS, all of the software, continues running. Doesn't even blink. Pull out the board, replace the processor, slam the board back in, tell the SSP to bring the board back up, comes online, breaks the processors, boots the processors, and then everything evens out again across the boards. Sweet. As well as this, the Gigaplane XB, we can go around to the back here, is a monster of a system interconnect bus. The center plane, which is a little hard to see, is behind the shield here. Now, it's rumored that one of these center planes, which goes from the top corner all the way around, cost $500,000 to replace. So you did not want to break this. It's covered in ASICs, and it uses a system router to packetize data going back and forth between system boards and system board RAM. And it can move 12.8 gigabits per second across the bus. It used a 16 by 16 crossbar, which meant that at any given point in time, any system board could be directly connected to another system board. Now this is important because instead of like the SGIs over here where it talks from this system to that system's router over to that rack, and then it queries that system for the data contained in its memory. Say processor 0 on this system board wants to get something from bank 4 on this system board. It is literally directly connected and then can DMA back and forth between. The lookup time between any processor to any RAM anywhere in the system is 500 nanoseconds. So, extremely well designed. As well, you can see that there are bus slots here. These are S-Bus cards, which are the Sun proprietary boards like PCI Bus. They have S-Bus. Each system board has 4 S-Bus slots. So again, that allows for a maximum of 64 S-Bus cards. You can also get a riser which allows you to connect PCI cards to the system. There is a control board, which is this one here. Control board connects to the SSP through the hub, which is up there. And the control board is what actually regulates the system. It provides the JTAG interface to the system. It provides the clock for the system, and it also provides AC sequencing and controls the fans, the power supplies, and things like that. So if a fan pack fails, it's the control board that finds out, and the control board tells the SSP. We also have a center plane support board. This board provides JTAG and the clock for the center plane alone. It also provides appropriate power for the ASICs that are on the center plane. There are two center plane support boards and control boards. So this is the first side. This is, I think they call this the back of the system. I'm not sure why, because system board 0 is on this side. But you have control board and system center plane board here. And then you have the second ones here. You can see here, CSB1 and CB1. So you've got a smaller slot up here. You can see the rail, and then the larger for the control board down there. And then here's the Ethernet hookup to it. So, as well as the system reliability, you can also use 2 SSPs. And this is actually the system SSP right now, or rather, this system's SSP. And you can see I've got it taken apart right now. It's a Sun Ultra 5, and it should have all of the software that's necessary to bring this system up. They have EEPROMs on this system which have the licenses required to bring the system up. Each system board had its own license ID code, so Sun could sell you a fully stacked system, but you would only pay for, let's say, half of it. And you weren't actually able to use the other system boards that would be on the back. And as you got money, you'd pay it to Sun. Sun would give you another license key which would be incorporated into the EEPROM, and you could use the system boards. Even though you already had them, you could then start using them. The SSP is obviously also runs Solaris, and it controlled the entire E10K. The E10K, unlike the 6400 and similar systems before it, is totally useless without the SSP. The SSP tells the system to come up, it tells the control system board to bring the fans up, to bring the power supplies on, and it also provides the boot OS for the E10K. It also has complete configuration information, so the E10K is as dumb as a post until this thing tells it how it's supposed to be configured. As such, you can't go anywhere without it. Mine apparently has bad RAM. When it boots up, it tells me memory address not aligned, which of course, thanks to the wiles of the internet, there's like 300 different reasons as to what the hell this says. I'm going to assume for now that the memory was bad when I got it. These two boards here were actually in the 3rd and 4th slots. So I think maybe somebody worked out that the RAM was bad, took the 2 good sticks out, and then just left it there. This is just standard EDO, so I shouldn't have too much trouble replacing it. Haven't gotten to it yet. Sure hope it has the keys on it. However, thanks to a very clever chap out there by the name of Tonu, who worked out that you can use GDB to break it when it tries to do the system keys, because it does the compare in memory in the SSP. So if you GDB the compare, you can see what the damn key's supposed to be and crack it from there. So, where were we? The system consists of not only the system boards themselves, but, oh, the SSP, that's right. I've had too much coffee today, give me a second. So, to go along with the fault tolerance of the system, you would have 2 SSPs, and they would work in concert with each other, and you would have one plugged into this hub, and one plugged into this hub, and then this hub talks to this control board, and that hub talks to the other side's control board. And the system is able to run with one control board. So if this one fries, then you can run it from the other one. If one of the SSP dies, you've got a second one to run the system. The fault tolerance allows the system to run with, now let's see, if you have 8 system boards, you can have, out of 4 power supplies, 1 can die. One of the AC input modules, I think, can die. One of the hubs can die. I think up to 3 of the fans can die. So, obviously, what they were going for was a system that would run for years and years and years. And if something a little flaky happened, pull it out, trade it back with a replacement part. The system will run for a week or 2 until Sun can get it to you, and you're good to carry on. These big babies here are the AC sequencers. You can see up the back there, those are the disk boxes. Walk around. So it came with a pair of D1000 disk boxes. Naturally, all of the disks have been removed. And I don't have any of the spud trays. Now, remember I said that it has to boot off the SSP. So those disk boxes, you can't boot off those. You can use it for storage. And you can see we've got SCSI cabling here, which I got tucked out of the way, and they would connect to the S-Bus SCSI cards. And then we have the 2 hubs. Now these run on 110. The system runs on 220. So these big monsters here convert the 220 to 110, and they will, as the name suggests, sequence the power up. So you tell us SSP to bring the system on. You tell it to bring the system up. The control board will... I think it brings these up first, so it will Actually, these would have to be up first. So maybe you're supposed to run one of these in local mode, so when this comes on, both of these come on, and then you run that in remote mode so that it brings the disk boxes up independently. Anyways, sorry, I'm working it out in my head. The idea of the sequencers is, instead of having all of the 110 units powered at once, because keep in mind, we've got 2 quarter racks here, so you could have a lot more gear in here than this. It would bring each of the devices up independently, so you don't have this huge inrush current. So, you know, as with most electronics, when you turn it on, that's when it sucks the most juice, and then when it gets warmed up and, you know, the disks have gone from spin up, which takes more amperage, to a coast, you're not blowing your breakers out by bringing it all up at once. The same goes for the boards. Each of the boards are brought up independently. This little thing here is actually the front end of the sequencer. The control board will, through DB9, go to this, which then goes to the sequencers. And you can have several peripheral racks. And so you would go DB9 to this, DB9 to that, and that would stay for this rack, and then you'd have another one of these, and you'd stick it here, and it would go to the next rack, and then another one would go to the next rack, or you could just daisy chain each of these. So this to this, to this, to this, to the next rack, the sequencers in that rack, and the next, and the sequencers that rack, and it'll all come up independently. We have AC line in. These big babies do power smoothing, regulation, make sure there's no spikes. These convert the in AC220 to DC 48 volts. So the system plane provides 48 volts to all the system boards. The support board here will provide 5 volts and 3.3 volts for the ASICs. Those are the routers and the crossbar on the center plane support. And then each of the boards themselves have DC-DC converters, which take the 48 volt down to the 5 volt and the 3.3 volt. We go look over here. I have one of the boards open. Let's pick her up. Oh, and it weighs a lot, believe me. So, my boards have 400 megahertz processors. So it's not the top of the line. The low end was 250 megahertz, the high end was 466, but it's still pretty damn good. So each of these is the processor, and we have 4 gigs of RAM. We have some ASICs which do cache snooping and things like that. These are our S-Bus boards. This is the S-Bus slot. We've got SCSI controller, we can tell because it says QLogic, and then a quad Ethernet port card. I've got a convenient carry handle here. Oh, and on this side, flip her over without dropping it, we have, these are the big DC-DC power converters. So these provide the 5 volts, 3.3, whatever else these things use. This is another DC-DC converter. That's what these big babies are here. And then these are all of the ASICs that handle the routing to the center plane. Over here we have the center plane support board. Again, DC-DC converters, regulation, and then presumably this provides the JTAG, and somewhere on here there'll be a clock source. Might be this one. Anyways, and then we have the system support board. More big DC-DC power converters. This is the header board for the DB9s, JTAG, so on and so forth. Now this system board, apparently somebody dropped. This is the cover. You can see the rather mangled end on it. So, I have no idea if it's still good. If not, we'll be down to 60 processors instead of 64. Oh well. This is the 48 volt power supply, so this takes the 220 AC, provides the 48 volt DC for the system, and then this is the AC line in power module. So, what are we going to do next? Well, hopefully this coming week, I'm going to go and buy a pair of power plugs for it. Now, you've heard me complain about these freaking twist locks, like all of the Onyxes have them. And for each different amperage, the twist locks have a slightly different plug format. Some of them have this 90-degree angle on the pin, some of them don't, and they're all different diameters, which means that for the 30 amp, the 20 amp, and the 50 amps, they're all freaking different, and it is really annoying, and these things are very expensive. The receptacles go anywhere from $50 to $100, so I'm sure as hell not buying a bunch of these things that, you know, I've got the 20 amp ones, and then I've got the 30 amp ones, and then I've got the 50 amp ones, and, you know, depending on what the hell I'm plugging in, it's bigger or smaller. Yeah, I just don't think so. So what I'm going to do is I'm going to nip this whole thing in the bud, and I'm going to standardize them. This cable here, with the, or this plug here with the twin cables, goes to the AC line ends. So each one of these cables goes to one of these. And then these big beasties here go to the sequencers. Now, I don't need the sequencers. I don't need, oh, sorry. I managed to tear my meniscus in my knee. So I'm in for orthoscopic surgery in a couple of weeks, which will have me on crutches. But anyway, not to whine. I just don't move like I used to. Oh, look. I missed some freaking sand. Piss me off. Anyways. So I don't need the sequencers because I don't need the disc boxes, so I'm not going to power these up at all. In fact, I'm probably going to remove these bloody great big things. Let's pry one out. Oh, is that a bastard or what? Good grief. So, I'm going to pull all these cables out, and I'm just going to run, because I've obviously got only the single SSP, I'm going to run a single hub, and I'll just plug it into one of the 110 outlets. And I have 150 amp outlet here, and if you'll ignore the fucking cat, there's another one over there behind my wife's stuff. So I'm going to run that one over to here, and I'll have a pair of them sitting here, and I'm going to use, I know I started this, it's a tangent, but I'm getting back to it. I'm going to use oven, or dryer, or range, or whatever you want to call them, standard NEMA plugs. And it's the exact same kind that I used on the Onyx in the office. And then the 50 and the 30 amps are almost identical, so you can use the same plug. And they are cheaper than dirt. For the plug, the combination 30-50, it's like $7. And for the receptacle, it's $5. So I can buy a pair of receptacles to give me two 220 outlets. And I can buy a dozen of the damn plugs and replace these with the standard NEMA outlets, the 1050 and the 1030Ps. I can replace the twist locks on those with standard NEMAs, and then anything I can just roll over here, I can plug in to the standard outlet and bring it up. Now obviously things that are using the 30 amp plug, I'm going to put the 50 amp socket on. Not entirely kosher, but let's be honest, my breaker and my house are more likely to pop before I actually start frying things, so we're probably safe. So in theory, with two of them, I should be able to bring up one entire side. I'll probably start with a single and just bring up 2 or 3 boards to get the system up and running, and then I'll shove as many in as I can until it flouts over and dies. But that obviously requires me fixing the SSP. Now, somewhere here, I got this the other day from a friend of mine in California. You'll note this is, 4 inches thick, and ta-da! It's a Spark laptop. It's actually got a dock on the bottom of it, so half of this thickness is a dock with extra ports and I think 2 or 3 3.5 inch drives. Fortunately, the boot disc on this is bad, but it would be kind of slick to get rid of the Ultra 5, which frankly I don't need another Ultra, and put the SSP on this laptop, because this runs SunOS, Solaris. And then if I run the SSP from that, all I need to do is copy the keys over, and hell, I can keep the laptop in the freaking E10K. So, SSP, get the data from it. I'm going to shoot the cat. I'm going to kill it. Not on camera. And then the plugs, the receptacles. And I think it should just work. Wouldn't that be novel? I mean, honest to God, wouldn't that be nice for something to just work? And I'll probably burn the damn place down first. Anyways. Shoo! We have the E10K. You might note that my disk is vaguely clean right now, and it's changed color because of the dampness. I pointed out last time my beautiful bench molded over. So I sanded the whole thing over a weekend and painted it with this oil-based enamel paint, which stinks to high heaven. And then, my $1,000 dehumidifier, which will do up to 2,000 square feet. Obviously 40 by 40, this is 1,600 square feet, but it is 14 feet high. And it is beautifully dry in here. My paper, look, listen, it like crackles like paper's supposed to, instead of being wet and spongy and flibbery. So this is good. Made my wife extremely happy because she has cardstock everywhere, like thousands of dollars worth of cardstock. And ruining all of that would have really pissed her off. And as any man knows, keeping the wife happy is the key to a happy home. Well, there we go. A half-hour bullshit rant on the E10K and the histories. I have not forgotten the Z80. The last time I tried to plug it in, I had exceptionally odd things happening. So the humidity in here is almost certainly not helping with it. So now that it's dry, I'm going to fiddle with this probably next week, and then I'll hit the Z80 again after it. And maybe we'll get a bit more progress and I'll get another video up. I appreciate you guys watching. I thank you very much for all the comments. I hope you guys have a good day. Take care now. Adios.